you all are fine and doing well. You are reading very well and you're watching my videos properly to get the proper explanation of each and every topic from chapter 1 of your science book. So without wasting time, let's get started today. And today is a very special video because in this video we are going to share the questions answer, the in question answer. On last video I told that few question answers are there which will be discussed on the next video, right? So today is that video, that very important video. Please get ready with your pen and copy. Whatever I will discuss here, you please note it in your copy so it will make a perfect answer for each and every in-text question. Okay, as we know the in-text question are also very important. Okay, so let's get started. So here the first questions that is page number, I'm telling you page now, page number 9. Open the page number 9 from your science book, NCERT science book. It is there questions. There are total 4 questions. Okay, the first question is given: convert the following temperature into Celsius scale. Okay, so here the temperatures are given. You can see here in number A 300K and B 573K. So in Kelvin scale numbers are given. You have to convert into degree centigrade. How it will be possible? For these purposes I am giving you the calculations over here. You please check it out so it will be easy for you. Mainly what you have to do, you have to subtract 273 Kelvin from the given number. Then the answer will come as a degree centigrade. Okay, so come to the number 2 questions. What is the physical state of water at? So here you can see in number A 250 degrees centigrade and 100 degrees centigrade. Two temperatures are given. So based on these two temperatures, what will be the physical state of water, you have to say. So easily we can say that number A, that is given 250 degrees centigrade. As we know that water starts boiling at 100 degrees centigrade, right? So if there is 250 degrees centigrade, so what will happen automatically or easily? The entire water will convert into gas formation. It means it will remain as a gaseous state. Okay, now to number B. What is number B? Number B is saying as 100 degrees centigrade. 100 degrees centigrade is the perfect or actual temperature at which water starts boiling and it starts evaporating. Okay. So evaporation process starts at the 100 degrees centigrade. Okay, we can write the answers from here. Now come to question number 3. For any substance, why does the temperature remain constant during the change of state? Yes, we have already read that when the ice cube melts into water. So every time we see that throughout centigrade thermometer that in when the water was in ice solid form, that it was showing 0 degrees centigrade, and when it melts already and after that also it is showing the 0 degrees centigrade. So how is it possible? And that time we discussed about a kind of energy that is called the kinetic energy, right? Kinetic energy is the actual energy that helps to make or helps to absorb the or helps to pack the entire type of homogeneous or heterogeneous particles along with it. Okay, and when it is changing its shape, means structure from one structure to another structure, or just for conversion, okay, of their states, at that very time they used to absorb a little bit of external energy, means the outer energy, that is called the temperature. Okay, so that very minimum room temperature is used here for mixer, but their energy or their temperature remains at that very time. Okay, so why the temperature remains same? It is only because of the kinetic energy. That's it. Now come to question number 4. Suggest a method to liquefy atmospheric gases. Look, in chapter 8 of yes, chapter in science you have read coal and petroleum in class 8. There you have read about the LPG and CNG. On last video also I have told that by the compression on the natural gases, it converts into liquid. So the same process we can use here, that the huge pressure and very cool temperature. Okay, and when the temperature is being reduced and pressure increasing on the atmospheric gases, so automatically convert into liquid. That's it. Okay, so these questions are completed. You please write down the answers in your way. I told the answers. I already just given the actual words, that what should be there in your answer. Now you please write it down in your copy, and don't forget to send me through email. Okay, that's it. Now come to page number 10. Page number 10 means on the next page, there are also five questions together. Okay, in text question. So these five questions are very easy. It is all about the that is convection, conduction, as well as the evaporation. All these processes are included over there. So let's get started from number one. So question number one is saying that why does a desert cooler cool better on a hot dry day? Okay, so why does a desert cooler or remains cool better on a hot dry day? We know that the deserted region, okay, suppose if we say for the Sahara desert or the Kalahari desert, so such type of deserted regions mainly on the daytime it remains very hot, right, very hot and very dry. So due to this non-moistured air, the entire region or in deserted region remains very dry, got it, and very hot. Okay, but if we say at the night time, whenever it is coming, the sun is setting and the night is appearing, at that very time the entire region remains, entire temperature atmosphere remains, means totally changed. Okay, at the time we have seen that the very dry and hot wind that blows, but at the night time from the same region very cool air used to blow. How is it possible? It is only because of the evaporation process. What is the evaporation process here? How it is working together? As we know the evaporation process, how it is working here. So we know that during the daytime, as the unlimited scorching of the sun rays is falling on the desert, means or falling on the sand. So the water particles, those which are present over there, we know that there are very minimum or no water molecules over there at all, but the water that is present over there, it is just evaporating itself continuously. Okay, and the lighter, as we know that it moves towards the sky. Okay, and it becomes very lightweighted, and to make the and to fill that very gaps from the surrounded from the outer regions. Okay, the cool air used to rush over there. Got it? So in this way a circulation process or a cycle process used to happen day after day. So that's why in the desert region we observe in the daytime the hot and temperate air, whereas at the night time very cool air. That's it. Okay. Now come to number two. How does the water kept in an earthen pot or matka remain or become cool during summer? Yes, during summer you often have seen that when you used to get the kulfi, okay, from any kulfi seller, we have seen that they use a large earthen pot. Okay, and inside a large earthen pot, they used to keep the water along with the ice cubes, large ice cubes, as well as the kulfis. Okay, the container of small kulfis are present over there, and we need the kulfi. They used to take out one kulfi container, and from there we used to give us the solid kulfi that is very icy cold. Okay, and often we use the filter. Earlier it was used the filter, those which are made up of earthen pot. Okay, means made up of soil. So such type of earthen filter earlier it was used. Now it is also in few houses it present. Got it? And why? What is the benefit for using this type of earthen pot? Actually, earthen pot in summer season remains the water. How is this possible? As we know that the soil, the pot or the container, those which are made up of soil. So such type of earthen pots contains lots of pores and small holes throughout its body. Okay, we cannot say that the entire part of the earthen pot is fully solid and there is no small hole. Of course not, there is also small hole, small channels are there, very atomic, we can say atomic channels are present everywhere. Okay, those which are connected from the inner region to outer region, but it cannot be seen. Got it? So whenever water is poured over there during the summer season, as we know that the outer or the external temperature of the earthen pot, it remains very hot. Got it? So that very time it has a tendency to absorb, to evaporate the water. Okay, and as we know that the earthen pot remains small pores or the holes or atomic channels are there. So through that atomic channels water will come out. Okay, very gradually it will come out. So gradually when the waters are coming drip after drip, so that very time the entire water is evaporating by the external temperature, as at the outside the around the surrounding part of the earthen pot there is a hot air, so it has a tendency to evaporate all that very water. Okay, so that's why the entire outer side or entire outer surface of the earthen pot remains very very cool, and this coolness helps to keep cool the water inside the earthen pot. Okay, so this is the entire experiment that is done by the earthen pot, and that's why in season whenever we used to take the water from the earthen pot, it remains very cool, and it that very time it relieves us. Okay, that's it. Fine. So let's go for the next question. What is the next question? Question number: why does our palm feel cold when we put some acetone or perfume on it? Yes. So this is our palm. So on palm, when we pour here the acetone, acetone means the nail remover. Okay, nail remover that helps to take out the nail polish from the remover. So that is the acetone. So this acetone, if we put here, or if we pour here the nail polish, or if we pour here the suppose the perfume or the that what is it, that the perfume those which are used for giving the giving on our body. Okay, so such type of things when we pour on our palm, we feel very cold, or anywhere on our body we feel cold. What for? So this is only because of the spirit that is present over there. Okay, the acetone that is present. This acetone is a kind of chemical that remains cool on our body when it comes in contact to our body. It remains very very cool to us. It gives a kind of relief to us. Okay, so that's why it is used, and as well as when it pours on our body, it is evaporating. Okay, continuously it is evaporating, and within a very single second it evaporates from our body, and such type of conditions also give us the relief, or it also helps to feel us cool at that very time. That's it. Fine. Number 4: why are we able to sip hot tea or milk faster from a saucer rather than a cup? Okay, why are we able to sip hot tea or milk faster from a saucer rather than cup? So when a saucer and a cup is given to you, and that contains the hot coffee or hot tea inside it, or hot milk inside it, now if you take the hot coffee or hot tea from the cup, so it will a little time to make it cool. What for? Only because of the surface of the cup is quite shorter. Okay, so that's why it will a quiet time to keep the cool of the hot tea or coffee, so that you can have it. But whenever you will feel a little part of what coffee or tea on your saucer, okay, so as the surface of the saucer is quite broad, okay, so that's why the entire tea will also be broad in a broad way. It will be fill up the gap. Got it? So it means that the layer or surface of the tea or coffee, it becomes thin. So that's why the hotness or the evaporation that was coming from the tea, it was less, rather the evaporation that will occur on a saucer, it will be more. Okay, so that's why on saucer, if we fill the tea or coffee at that very time, it becomes cool within a very simple time or single time, whereas cup takes a quite time. Okay, so that's why if we take on the saucer, so it will be take very short time to complete the tea or coffee, the hot tea or hot coffee. Okay, but it is not a good attitude, or I think so. That's why you must not you must not pour the tea or coffee on the saucer and have it. It is not a good thing, I think so, according to our gesture. Okay, so you always take the cup. That's it. Fine. Now come at the question number 5. What type of clothes should we wear in summer? It is already we all know, because on last video we have already discussed that cotton clothes. Yes, cotton clothes. This is a very good and very we can say that it is a perfect kind of fabrics. Okay, that can be worn only in the summer season. What for? As we know, the fibers, those which are added together or mixed together to make the entire garment, that pore, it contains lots of pores around it. Okay, lots of pores are there, and that pores allow the cold air or air, and it helps to contact to our body. Actually, our body needs the air. Okay, not our garments. So through our garments, if air moves and it touches our body, we get relief during the summer season, right? So that's why we often wear summer season, or mostly we wear summer season, the cotton clothes in the summer season. Okay, that's it. Fine. So questions answers are complete in this question answers. Now we will discuss about two more states of the matter. About two more states of the matter. As we have already read that there are three states of matter, that is solid, liquid, and gas. But except those three, there are two more. Which are those two? Number one, that is plasma, and number two, that is Bose-Einstein condensate or Bose-Einstein condensation, that is also called BEC. Okay, so now we will discuss on this two matter. What are such type of matters? As we know that solid matter that has proper shape and size, and we can hold it, we can take the actual weight of it, so it's okay. If I say for the liquid, as we know that liquid has mass and volume both, but it has no proper structure. According to the shape of the container, it takes the structure. Okay, that's it. If I say for the gas, as we know, the gas is totally invisible around us. Okay, gas is present in our atmosphere, but it is invisible. So that's why it has no proper shape and size, but it has mass and volume. So easily we can say that it is a kind of matter. Okay, so from a gas, we know that there are different type of gases according to their density. Okay, few of the gases are there, those which are very less denser. Few of the gases are there, those which are very means quite heavy denser. Okay, and so based on this density, the stages of remains in the atmosphere as a layer in the atmosphere. There is also differences. If we say the nitrogen gas, then oxygen gas, then carbon dioxide gas, carbon monoxide gas, such type of gases are quite heavy denser than any other gases in the atmosphere. So that's why they remains always in the troposphere and mesosphere. Okay, if I say for the ozone gas or the such type of gas, as we know that ozone gas remains in the ionosphere. Okay, as is, if I say helium gas, hydrogen gas, look, such type of gases are so lightweighted. These gases weight or density is so low, that's why they always remain in the space, means stratosphere. Okay, so in such way, in our layer of the atmosphere, different gases are present. Okay, now except these, the, there are few type of noble gases are also present. Noble gases means the gases those which have proper structure, those which have proper volume and proper mass of it. It means this is a kind of matter, but it has a kind of unique power that helps to glow. It means it helps to glow itself. That's why it is called a kind of noble gas. As well as there are also a few characteristics more there. You will read in class 10 when we will discuss about the periodic table. Okay, so among them there is a kind of gas that is known as a neon gas. Okay, NEON. So neon gas is a kind of gas that helps to glow itself. Okay, as well as if I say for the helium gas, okay, hydrogen gas, such type of gases, when we used to produce electricity through it, okay, at that very time it starts glowing and it gives the glow, you see, it provides the light. Got it? How is this possible? In open air, if we provide electricity, so will this glow? Of course not. So how is it possible? At first we have to take a medium. We need a medium. Suppose if we take a cylindrical or oval shaped, round shaped, or any kinds of structural, a glass particle, okay, a glass part, got it, that is almost look like a chimney, that is almost look like a oval shape or round shape or any other shape, but the inner part will be hollow of it. Okay, inner part will be hollow of it, and from two sides, from any two sides, there will be a channel like structure. Through that channel, wires can be connected. Okay, wires can be connected. Okay, so suppose it's a kind of cylindrical, I'm taking a cylindrical glass tube. Okay, the inside part is fully hollowed, and the two mouths are connected through the wires. Got it? It means if the wires helps to take the negative and positive ion over there. Got it? So when through the electric where the ion is providing or the electricity is providing, and if we take the neon gas, if we take the other fluorescent gas like the helium gas or hydrogen gas inside the tube, and if we provide electricity, what will happen? The particles of those very type of gases will move very fast. Okay, will move very fast, and they will react together as a highly reactivity manner, and they will provide the light, or they will glow itself. Got it? So in such process, plasma used to occur. And if we say basically in our nature, where such a plasma can be seen, look, in our sun. the sun that is present, the stars, those which are present, it used to glow itself every time or constantly. How is this? Only based on the plasma condition. Okay, plasma effect is remaining there and it is continuing itself. That's why it glows. Got it? Why we cannot see the sun for a long period of time? Okay, only because of this plasma effect. The plasma effect, that is, it means the eruption. We used to say na, that eruption is happening. Okay, the different glittering conditions are coming to us, so that's why we cannot see the sun properly. So all these things used to happen continuously everywhere in each and every core of the sun. It is plasma. It means everywhere the ions are working together along with the hydrogen gas, helium gas, and many other gases, those which are present in the sun. It helps to make the plasma condition. That's it. In the stars also. Okay, that's why in night sky stars used to twinkle every time. Okay, so it's very common. I think you understood. Now come at the last or fifth state of the matter. That is Bose-Einstein condensate or Bose-Einstein condensation. What is that? Actually, for making this, at first it was thought by our Bengali scientist, okay, Satyendranath Datta. First of all, he thought and he made a kind of calculations based on, we can say that, kinetic physics he used, okay, and then thermal physics he used. So based on such type of physical method, he made us a kind of calculations and he tried to found out another type of matter. What is that type of matter? He made up to the calculations. Now, these calculations was taken by Albert Einstein. Okay, he was examined or he was experimenting on those calculations, and the calculations and the what is it, the method that was taken for making the another type of state that can be exist in our world. For this, they use a very low temperature. Okay, very low temperature means it is said that 100,000 degree less than the normal temperature. Okay, 100,000 degree less temperature than the normal temperature of any substances. They experimented on sodium, they experimented on helium, they experimented on hydrogen, they experimented on different type of matters, and they found out that it where there will be any type of other matter presence or not, when we used to reduce their temperature in a maximum level. Okay, maximum level. So they were succeed, and commonly we have got the experiment, and we have got the proper explanation on boson Einstein condensate. Okay, in 2001, and in 2001, based on this, a scientist also got the Nobel Prize. Okay, so you all will read from this topic. I have just told you the actual matter. What is that? Okay, so in this way we have already completed the topic, and we have already completed the chapter. You have to read the chapter because the entire chapter is most preferable at first, then you will listen to my video. Okay, then it will be more better for you to understand.